Yo, what's good? I got a quick question for today. This is a calorimeter question, so let's get into it. Thermochemistry. 9-gram ice cube initially at 0 degrees is put into a cup of coffee at 363 Kelvin, which contains 120 grams of liquid coffee. Assume that the heat capacity of coffee is the same as water. The enthalpy of fusion of ice is 6 kilojoules per mole. Calculate the temperature of the coffee after all ice melts. Okay, so we got an ice cube. And then we're going to put it into a cup of coffee. What's 363 Kelvin to degrees? 90 degrees Celsius, okay. 90 degrees Celsius. So what's going to happen is that this 0 degree ice is going to go into that 90 degrees Celsius coffee. Now what will happen? Well, the ice cube heat will go into coffee. Ice cube goes to coffee. So the heat of the ice cube, heat lost, or wait, okay, now I'm getting confused. Ice cube, so the heat of the ice cube, but I mean, does the ice cube even have heat? I don't know. Interesting. Okay, so, bro, this is low-key getting a bit confusing, bro. Warming the result. Okay, so the temperature of the coffee is going to go down. The temperature of the ice cube is going to go up. So, what ice cube? How do we even start doing this, bro? Okay, so coffee is going to lose temperature. Okay, so whatever is lost by the ice cube is going to be gained by the coffee. So therefore, Q ice cube has to be equal to negative Q coffee. Okay, that's a good start. Now, in order for us to find out what it is, because these are both going to have the same temperature final, so we just got to sub these together and find it out. So I guess that's what we will do. I don't know what else are we going to do. So Q ice to water, we're going to have to go to the enthalpy of fusion. Okay, so that's why they gave the fusion, plus whatever extra it changes by. And this is where we're going to get our RTF. And negative Q coffee, this is just going to be equal to MC change in T, and this is also where we're going to get our change in temperature. So that's pretty simple, I think, not so far. So we'll just split this into two and do the first part here. Okay, so we got, and we need to find out, 9-gram ice cube. Okay, what's the molar mass of water? H2O, 2 times 1, 18. 18 grams per mole, yeah. Yo, wait, no, I forgot to get the multiplied by 9 grams. Oops, forgot that part. Okay, 3,000. Okay, so that's going to be change in H fusion. Now we need to figure out MC change in temperature. This is going to be equal to, because we're looking at the water or the ice right now. So that would be, what's mass? 9 grams multiplied by specific heat. We're at 4.18 joules per grams degrees Celsius times the change in temperature. So what is the initial? 0 degrees. So it's TF minus 0 degrees Celsius. So what's 9 times 4.18? 37.62 grams. Units might be a bit tricky on this part. Okay, so this part is just going to be 3,000 joules plus 37.62 joules per degree Celsius. Now this part, mass of coffee 120 grams multiplied by 4.18 multiplied by change in temperature, which is initially at 363, so this is going to be TF minus 90 degrees Celsius. Damn, this is messy, bro. Negative 120 times 4.18. Negative 501 joules per degree Celsius multiplied by TF minus 90 degrees Celsius. So now we just gotta set these two equal to each other. That was the wrong arrow. Okay, bro, my work is looking not the best, bro. Could have made this a bit more neater. We'll just move on to the next page. Okay, so what do we have here? 3,000 joules plus 37.62 joules per grams degree Celsius is equal to negative 501 joules per degree Celsius. Wait, why do I have grams still? I shouldn't have grams. Negative 501 joules per degree Celsius times TEF minus 90 degrees Celsius. Okay, now what? Now we just expand and solve for TF. Okay, that's pretty easy now. Hold on, something's missing. 3762 multiplied by TF. Okay, so now what do we do? Okay, we just solve for TF. Bro, this can't be that hard. 37.62 joules per degree Celsius TF 1000 joules equals negative 501 joules per degree Celsius times TF plus 90 times 501. Whoa, that's a big number, that right? Am I tweaking? Wait a minute. What's going on? Negative 501.6 plus should be 120 multiplied by 90 multiplied by 4.18. Ah, there you go. 45144 joules. Okay, bro, my writing is low-key a bit too messy, bro. Now I'm okay. 37.62 joules per degree Celsius times TF minus plus 501 joules per degree Celsius. Oh my god, bro, I literally did this question, bro. 37.62 joules per degree Celsius plus 501 joules per degree Celsius times TF is equal to 45144 minus 3000, which is 42144. Nice. Now what is 37.62 plus 501? Okay, 538.62 joules per degree Celsius. I didn't use exact values here. Times TF 42144 joules. I forgot to put joules. Okay, there you go. TF is going to be equal to 42144 joules over 538.62 degrees Celsius multiplied by joules. Wait, what? Divided by joules. There you go. This should be the last. Divided by 78.2 degrees Celsius. Boom, that's the answer. That was kind of difficult. But yeah, I'll see you tomorrow. Goodbye.